A motel finds that it can rent 200 rooms per day if it charges $80 per room. For each $5 increase in the rental rate, 10 fewer rooms will be rented per day. What room rate maximizes revenue? So the function we're being asked to optimize is the revenue function, and we know that the revenue will be the number of rooms times the price per room. So let's define our variables here. I'm using capital R for revenue. Remember, math is case sensitive, so you have to stick with one case for each variable. N is the number of rooms rented, and P is the price. But we have the same problem here as we did in the last example, namely there's two variables in our function. And we don't have a way to deal with two variables. We need to have just one. But we have this other information that they're going to be changing the price using $5 increases, and based on how many increases there will be a different number of rooms rented. So let's have a variable that is the number of these $5 increases, because that's kind of how the problem is stated. And using that idea, the number of rooms rented, well, the basic number of rooms is 200, but then 10 fewer, so I'm going to subtract from the 200, 10 fewer rooms will be rented out for each increase in the price rate. So for example, if they raise the price by $5 once, you'd have only 190 rooms rented. If they raise the price 2 times, so by $5 and then $5 more, they're going to lose not 10, but 20 rooms, etc. Then the price, so the base price here is 80, and we're going to be increasing it by $5 some number of times. So if I put those two expressions into our revenue function, N is 200 minus 10 times the number of price raises, and P, the price, is 80 plus 5 times the number of price ranges. And so maybe we should come up here and clarify that when I say P for price, it's the price after the increase. So now we have a function of just one variable. The only variable in there is x. So I can deal with that. But we need to know the domain, because remember, the domain determines how we're going to proceed. And the fewest number of price increases we could have is 0. So I can't increase the price any fewer times than 0. What's the most number of times I could increase the price? Well, if you look at this formula for the number of rooms being rented, eventually you're going to get down to renting 0 rooms, and you can't rent a negative number of rooms. So the max value for x is when the number of rooms gets all the way down to 0. So let's see, that would say that 10x equals 200. So x is 200 over 10, which is 20. So the maximum value we can have for x is 20, because if you raise the price more times than that, you're theoretically renting a negative number of rooms. Okay, this is a closed interval, so we can use the closed interval method. It's an interval with two endpoints, and it contains both of them. In other words, we're saying here that x is between 0 and 20 and could include either of those. Obviously, 20 is not going to be our answer because we're down to 0 rooms, and if you rent 0 rooms, you have 0 revenue. But still, theoretically, that would be a possibility. Okay, let's differentiate for our closed interval method. Before I do that, though, I'm going to multiply out this expression for r so that I don't have to use the product rule when I differentiate. I'm going to write that as r of x just to emphasize we have it and now as a function of a single variable. So let's see, 200 times 80 is 16,000. And then I have plus 1,000x minus minus 800x, and then minus 50x squared. So my revenue is 16,000 plus 200x minus 50x squared. Derivative then, r prime of x, is 200 minus 100x. Now I'm going to look for critical numbers. This function is always defined, or maybe I should say it this way. This function is never undefined, so we don't have the type of critical number where the derivative is not defined, but 200 minus 100x equals 0 would give us x equals 2. So that's our one and only critical number. It is inside our closed interval from 0 to 20, so it's one we can use. So with the closed interval method, again, we just plug in the critical number and the endpoints. And whichever one is the biggest is our maximum. Okay, so for r of 2, and remember we're plugging into the original function r, not r prime. So if x is 2, I'm going to have 16,000 plus 200 times 2 minus 50 times 2 squared. And that works out to be $17,640. If we don't raise the price at all, so 0 price raises, we already know that we can rent out $200 rooms at a price of $80. So that was given in the problem. That's our basic information. You could plug 0 into, in fact, let me point that out. I could plug 0 into my formula for R of x2. So that's going to be the same thing as if I do 16,000 plus 200 times 0 minus 50 times 0 squared. So you can either use the original information that was given in the problem, or we can use the function we set up. Either way, we get 16,000. And as we said a minute ago, if we increase the price 20 times, we'll end up with zero revenue because we'll be renting out 0 rooms. So our 3 function values here, 17,640, 16,000, and 0. The maximum is clearly the 17,640. That's our absolute max. So we can conclude that the price should be raised 2 times. So the price that gives maximum revenue is 80 plus 5 plus 5, so that's $90 per room.